Hi everyone, in this video we will talk about the different ways of signing in Tezos and the risk associated to each of these solutions. So, there are some supported scheme, elliptic curves algorithm on Tezos from the addresses from TZ1 to TZ4. So you may know the default one in Tezos, that is ED 25519. The TZ2 address, that is a SecP 256K1. The TZ3, the NIST P256R1, and the TZ4, the BLS1. So for the TZ1 address, that is the default address on Tezos, it is an elliptic curve that is quite fast and efficient, but is not very used and supported by cloud providers. The second curve is for the TZ2 address, and it was not very famous before it was becoming popular with Bitcoin and Ethereum, and now it is quite used on the market. The TZ3 address is a NIST P256R1 and is becoming more and more popular since we use more and more by biometrics and FIDO, and it is used on your secure mobile with secure enclave and is supported by most of the cloud providers. The last one is a TZ4 address. It is a BLS algorithm. Lin Shasham. It is a digital signature. It is quantum resistant and has good properties using multi-sig. Okay, for dapp architectures, we are going to see the self-custodian wallet. The private key is embedded on your application. How to protect this private key. Also, the solution where the private key is not on the dapp but on a wall that is separated with another devices. And you see how to protect that through communication. Other non-custodial solution with wallet as a service as third-party HSM. And on the last part, I will talk about multi-signature on smart contract. So for self-custodian wallet, I mean that you own the private key. It can be embedded or on a vault that requires a communication. Everything starts with a private key. So when you generate a set of private and a public key, you need to protect this private key in a way that any hacker can steal it from you and so steal your phone. The common way to protect a private key is to protect it with another protection like a password that we're going to see on the next slide. Today you can use a private key on your dapp using, for example, an in-memory signer using Tatito, but it is a development feature. You have to not store your private key on your dapp like this or it gets stolen. To protect this private key, most of the time we use a vault protected by a password on your device. You have a common example on Tezos using the Beacon SDK with post message. With a wallet extension that is the vault. It is protected by a password, and there is the Beacon protocol interacting between your dapp and this wallet. This protocol and this extension is local on your devices, so you don't have to pass through a network. It is secure, but it has some weaknesses. For example, it is protected by a password that it could be weak, and because your device is connected to the internet, someone can try to hack and brute force your password. You can have also a keylogger that is installed by a hacker on your machine, and it will try to record your keyboard and what you try to type your password. Another way to remove the weaknesses of the password is just to remove the password. So on the Web2 application, on banking apps application, you see more and more biometrics controlling the access to the private key. It is the same for Web3. So your device, like a mobile phone, has a secure enclave or a trusted environment or trusted zone. It is acting like an HSM, hardware security module. So your private key is inside of this secure enclave, and the way to access to it is not using password, but use your biometrics like your face, your fingerprints, or the iris of your eyes, for example. It is a bit better than the previous solution, but it has also some drawbacks. Biometrics can be copied. Someone can copy your fingerprints and access the secure enclave. You have a UX problem of importing, exporting from the enclave the private key. It is good for security in a way, but it's a bad UX on the other side, but you cannot sync your private key among different devices. It's good for UX on the other side because I can quickly unlock and access the private key to sign whatever message, just to sync the screen. So you saw the solution of you have your vault on your device, but what happens when you have your vault that is separated to the dapp? In this solution, there is a need of communication between the device where is your vault and where is your dapp. The most common way is to use hot wallet. Again, you have the beacon protocol, but you have also wallet connect on Tezos. For beacon, it supports post message like we saw locally, but it uses a relay network, or it's a beacon network, and the relay will relay your messages and communicates between one device on the side and the other on the other side. Through the protocol, you are able to log in and to sign your messages. Like you can understand, you have the ownerships of these two devices. There is a relay in the middle, and it is a third party. This relay network is mainly centralized today or partially decentralized, depending on the solution. So you have to trust and to rely on the availability of this relay. Another solution is to use an HSM, a hardware HSM like Ledger or Trezor. It is a secure hardware that you have locally, and it needs to communicate between this hardware and your dapp, and the way to do that is through Bluetooth or cable. It is good because you don't have to go through the network, and your HSM is protected by the PIN. So if you lose the password or the PIN the same, or it gets stolen or the device is destroyed, you have no way to recover your private key. There are other solutions given by Ledger, like Ledger Recover, when you can try to do this recovery, and let's have a look to see that on the web. Also, you have to be careful on unsecure Bluetooth communication. If you take, for example, a cable on the airport and you connect your Ledger with this cable and it is a USB spy cable, it can also sniff your message and post it to the attacker. Another solution is to use an HSM but on the cloud. This time you instantiate an HSM service on your cloud provider, and you pass through Taquito remote signer and signatory to forward your messages to this service on the cloud. You still have a third party that is a cloud provider, and you have to trust this cloud provider that he cannot read inside the HSM and has no control over it. you could have also a problem of availability if the service goes down. Okay, let's see now other non-custody solutions like wallet as a service and third-party HSM. So some providers propose you wallet as a service. There are different kinds. A fully custodial way. So the provider is a custodian. So he will propose you to cut your key in pieces and split all these parts to different parties. But it is on its own network, so you have to trust this third party. There is also a mixed way. So it's a combination of a service provider, but it's not only the service provider, it can include you. To recompose the key, you can use SSS, that is Shamir secret sharing. It's splitting the keys and sending her to different parties. It could be, for example, one of your device. What is good on this solution is that the reconstruction of the key is done on the client side, on the front-end side. The other way is using MPC, multi-party computation. The difference is you have still the partial keys, but the message is signed by all the keys passing the message one to the other. The example on Tezos is WebC Auth. It's a white labeling solution. The implementation for Tezos is called Kukai and is a custodial method. For third-party HSM, there are a service provider like Magic Link. They propose you to store your private key on their HSM service. As you can understand before, instead of you have to instantiate yourself HSM on the cloud, you have to authenticate through this service to get access to this HSM. For the UX is better because on the previous solution you need to be a developer. Here it is for an end user. You pass through a notification service, you authenticate, and then you access to the HSM. You have the same risk as before for the cloud provider, but now you also have the risk for the third party that propose you this service. He has a certificate authority. You need to authenticate. He could try to impersonate you to access your private key inside of the HSM service. It is also a single point of failure for DDoS attack. The last part is about multi-signature and contract. Previously, we saw a mix of custodial and non-custodial signature for the solution, but we can get rid of all the third-party providers. In fact, if we have a smart contract, we can try to have this backend, and you own this backend. So about multi-signatures, the difference is instead of having one private key, you have different private keys, like we saw before with SSS and MPC. But you will choose who you own the keys. It could be only you, or it could be you plus one of your trusted friends. There are benefits using a smart contract. Is that you can manage the keys, the rules over it, and add a recovery mechanism. And of course, you remove the custodial solution. The drawback, you have more complexity on the key management because you have several keys. So if you want to sign a transaction, you have to sign 3 times with 3 different keys. If you have someone in the middle that is part of the threshold to pass the transaction, if it's not available, it can also delay the transaction. In this example, for Tezos, you have the TZ-Save solution. It will deploy your own smart contract, and you have different ways to program actions and to manage the keys between different people. The risk level is the same of other solutions we saw before to protect the private keys. It's just that you have different private keys to protect. So all what I said before applies to how to protect private keys. Thank you for watching and see you next time. Bye bye.